though, because remember, we're kind of freely moving around inside the spacecraft, and everything floats. If you have, let's say you have soup for dinner, you put the hot water in, you reconstitute the soup, you open the bag, you take a spoon and you dip it in the soup, and you get a spoonful of soup. Now here on Earth, it's when we put a spoon in soup, what holds the soup in the spoon? Gravity, right? Gravity. Never really thought about why a spoon was made the way it was until I really got onto this gravity thing, right? So a spoon holds soup in it because of the gravity. When you get in space, gravity's not helping you anymore, but you get a spoonful of soup anyway. The difference is that the soup you get in a spoon is a big ball of soup that sits in the cup of the spoon. And the thing that holds it there is the adhesion, the stickiness of the liquid to the spoon, and then a thing that they call surface tension keeps the ball there. But you have to be careful because you don't want to break that up. You don't want that ball floating around. The nice thing is if the soup's too hot, and you're sitting here with a spoon, you got this big ball of soup in it, if it's too hot, you just let go of it for a while. And let it just kind of float around, do its thing. And after a while, it cools off a little bit, and you pick it out, you grab the spoon and eat it. We had a little problem one day when the bag we had tomato soup for lunch one day. And the bag was popped open too fast and the tomato soup came out of the bag. We had a big ball of tomato soup floating around inside the spacecraft, right? That's a problem. That's a serious problem because it's a liquid. And if it got behind the instrument panel, it could start shorting out some electrical stuff. And that's not good. So we're watching this ball of soup floating around trying to figure out how to take care of it. Well, you can't go after it with a spoon because if you touch it, you break the surface tension. This is something you'll learn in school. But you break the surface tension, now all of a sudden you got 1,000 little balls of tomato soup floating around instead of one big one. You can't go after it with a straw because the same thing will happen. And I always maintain this is why we send people into space. To figure these kinds of things out. How do you take care of that ball of soup? Well, really it was pretty simple. We got a towel and wrapped it around it and absorbed it. But I'll guarantee you there's no robot ever built that would ever figure that out. It takes somebody with a brain to figure out things like that. Okay? I know you're not interested in that, but I'm going to tell you anyway. Because it's part of living, okay? This is what you have to do to stay alive. I mean, you can't hold it for 14 days. I don't know anybody can do that. And after you eat and drink enough, sooner or later you got to do something else. I mean, it's just inevitable. It's the way we live, right? Okay. When I had to pee in space, I had a tube. I could pee in a tube, and it got collected into a big plastic bag. We're all emptied into that plastic bag, right? We had one plastic bag. I see a few smiles, so I guess you're with me. After a while, when the bag got too full, we had to empty it. So what we did is we opened the valve to space, and the vacuum of space sucked it all out, right? You'll never believe what happens to it. It turns into a cloud of snow. It is. It's an actual cloud of snow, and it's white snow, not yellow. You've all heard of yellow snow? Well, this was white snow. The problem we had with that was that cloud of white snow was going the same direction, the same speed, the same time we were. So we're sitting here flying, and here's that cloud, and we're both going the same direction. All we have to do is look out the window and see ourselves. So every once in a while we did a little mid-course correction to get away from that cloud. Okay, that's how we took care of that. Now, the solid stuff's a little different. That's the problem. You have to understand, Apollo spacecraft is very small, 220 cubic feet of volume, and I'll give you the comparison in cars. You all know what a Volkswagen Beetle is, right? Everybody knows what a Volkswagen Beetle is. Same size. So you just think, Get two friends, get inside a Volkswagen Beetle, shut the doors and stay there for 2 weeks, and you'll see what it's like flying in space in that small space. So, we didn't have a bed, we didn't have beds, we didn't have showers, we didn't have a toilet, we didn't have any of that. What we had were plastic bags. And I won't go into a whole lot of detail, but once you're done, you got to close the plastic bag, and then get a pen out and write your name on the bag, because the doctors back in Houston were determined that they're going to analyze all that crap after the flight. Okay, so we had a big canvas bag with all those little plastic bags in it, and that's how you keep this thing going. Very fun. It was kind of unusual because all the flights before ours had gone into an orbit very close to the moon's equator, because we knew what the gravitational constants were in that narrow band. Our landing site was 28 degrees north, which was way out, way beyond what anybody knew anything about. So we had to be very, very careful how we flew and watch out for some mountains on the surface. We actually came as close to the lunar surface, or the top of the mountain. We came as close as about 8,000 feet to the top of the mountain. Where normally we'd be in a 60-mile orbit, we dropped way down so that we could get Dave and Jim off in the lunar module down to the surface. And again, we'll show you a picture of the surface here. They left the next morning, went down the surface. They had about, let's see, we were about 50,000 feet above their landing site. So instead of coming down from 60 miles, they only had to go 50,000 feet, which is like 10 miles, which saved them an awful lot of fuel going down. And that let them maneuver a lot more when they got down to the surface than they would have